you did on the homework, you were calculating definite integrals, but it was kind of a pain and it was very time consuming. You had to find your change in x in terms of n, you had to find your x sub I, plug all that in, do a bunch of algebra, and then you could do the limit and the summation rules from there. Now we have a couple properties that are going to be really, really useful to us. The first property tells us if you have an interval, you can change the order, your upper and lower limits, by putting a negative out in front. So if I said like the integral from 1 to 3 of x squared, that's equal to a negative integral from 3 to 1 of x squared dx. So if you want to flip the upper and lower, you just have to add a negative to the whole thing. Second rule says if your limits are the same, it's equal to 0, which should kind of make sense. We're talking about these in terms of like area under a curve. So if I start here and end here, have we gone anywhere to calculate any area? No, so it's a 0. Okay, now then here is the most exciting piece from today. We've done antiderivatives. An integral is an antiderivative. And it turns out that if I give you these limits to evaluate, you don't have to do the whole summation and limit thing. You can just plug those into the antiderivative. So to evaluate the integral from a to b, you do the antiderivative of the upper limit minus the antiderivative of the lower limit. And so that is huge. That is going to save us a ton of time. So for example, this is a problem that we have visited several times already. We did this one with under and over estimates using 5 rectangles, and then with 10 rectangles, and then with infinite rectangles. So we've calculated this a lot of different ways. Now I'm telling you, all you really have to do is find the antiderivative of this. Antiderivative of x squared is 1/3 x cubed. Now, I always told you you had to put a plus c with that. If you have a definite integral, you can actually leave off that plus c. I'm going to show you why in just a second. We need to evaluate this from 0 to 3. So what I usually do, after I do the antiderivative, I put a vertical bar at the end to show me my limits. So now you just plug in, and you're subtracting. You plug in the upper one minus the lower one. So 27 times a third is 9, minus 1/3 times 0 is 0, and our answer is 9. The reason we don't need the plus c, if you had kept it, you would do 1/3 times 3 to the third plus c minus 1/3 times 0 to the third plus c. If you subtract those off, what happens to the c's? They're going to cancel every time because we subtract. So there is no need to even put the plus c on this one. If it's indefinite, in other words, if I don't give you the numbers to evaluate it, you have to have the plus c. But if I give you numbers to evaluate, you do not. Okay. Let's do another one. Here's an ugly one. Not really that ugly, it just has variables in it, so it looks ugly. I want the integral from a to b of x to the n dx. So we have to do the antiderivative of x to the n. So we know when we do an antiderivative, we add 1 to the power. And what would I have to put in front to cancel that? 1 over n plus 1. And I'm evaluating from A to B. This coefficient, would you guys be okay if I just pulled that out in front? So then I just had B to the n plus 1 minus A to the n plus 1. And since I didn't give you any numbers, that's all we can do. Just keep working this. Integral from 0 to pi of sine x dx. So what is the antiderivative of sine? Negative cosine. We're evaluating from 0 to pi. You can keep the negative if you want to just pull it out in front. A lot of times I just pull out my coefficients. It doesn't matter a bit. So then we do cosine of pi minus cosine of 0. What is the cosine of pi? If you think about the unit circle, pi is here, cosine is x. So it would be negative 1. Cosine of 0, 0 is here, that's the order pair 1, 0, so your x is 1. So the opposite of negative 2? I want you guys to do the next one. Okay, add 1 to the power, so that's x is 6, so we put a 1/6 in front. You can pull the 1/6 out if you want, so 2 to the 6 minus 0 is 6. 2 to the 6th is 64 over 6, so 32 over 3. Much easier, isn't it? So much easier. Okay, let's do some more complicated ones. So these are problems that I probably would not have even attempted to give you when we were doing the limit of the sum things, because this one would turn into a nightmare. It's awful, it's ugly, but it's no big deal now that we know how to evaluate these. We start off doing the antiderivative, and we have to do every term. So the antiderivative of 2x would just be x squared. You guys okay? I kind of skipped a step there. You bring down a 1/2 and 2 times a half cancel. Minus, okay, x to the negative 1/2. So if you add 1 to the power, you get a positive 1/2. You have to put the reciprocal in front, so that would be a 2. Minus the antiderivative of 3 would be a 3x. You're evaluating from 1 to 9. So if I plug this in, is it 52? Alright, look at this one. if it were just a 2x plus 1 squared, it wouldn't be any big deal to FOIL it out. And we could write this 3 times and cube it. Anything beyond that we probably wouldn't want to spend the time on. But we could do this antiderivative if we think about it. If you were to do the derivative, the exponent comes down, inside stays the same. So when you do the antiderivative, the inside stays the same. Add 1 to your power, so that would be to a 4th. So what do we need in front? A 1/4. Now you also see if you did this derivative, 4 comes down, inside stays the same, subtract 1, times the derivative of the inside, which is 2. So to cancel that 2, we need a 1/2. So I have 1/8 times 2x plus 1 to the 4th, from 0 to 1. So if I put in a 1, I get 4 to the 4th. Put in a 0, we get 1 to the 4th. Yep. Thank you. So that's 81 minus 1. So we get 80 times 1/8, which would be 10. And these are the exact values. This is not an approximation, a left hand, right hand, midpoint. This is the true value. Alright, I'd like to do a few more of these. Antiderivative of sine is negative cosine. The angle would stay the same, but if you did this derivative, you'd have to do the chain rule. So what else do I need in front? 1/2 times 0 to pi over 2. Two times pi over 2 is pi. 2 times 0 is 0. Okay, we've already done these. What's the cosine of pi? -1 minus cosine of 0 is 1. So -1/2 times -2 possible. So this is not, really the only new piece here is the plugging in the numbers and evaluating, because we have done the antiderivatives before. What is the antiderivative of secant tangent? Derivative of tangent is secant squared. What has the derivative of secant tangent? Secant. The derivative of secant is secant tangent. Alright, pi over 4 is like 45 degrees. So 0, 30, 45. Cosine would be radical 2 over 2, so secant is the reciprocal, would just be radical 2. Secant is 0. Cosine of 0 is 1, so secant would be 1. And we would just leave our answer like that. I don't need a decimal. Why don't you guys try the next one, see if you can get it. You might need to rewrite your problem without a radical. So you have to think of this as a 1/2 power. So if you add 1 to the power, that makes it a 3/2, which means you need a 2/3 in front. You're also going to need a 1/3 to cancel that 3 when you do the chain rule. So you had a 2/9 integral from 1 to 5 of 3x plus 1 3/2. So I plug in a 5, it's like the square root of 16 cubed. Plug in a 1, it's the square root of 4 cubed. So 4 to the third is 64 minus 8. So 56 times 2/9 is 112 over 9. Okay, let's do maybe 1 or 2 more. Suppose an annual population initially numbers p of 0 equals 100. So at time 0 there are 100. And its rate of growth after t months is given by this equation. What's the population after 10 months? So this is the rate that it's changing. The rate of change. If I want the actual population, I want the actual number, what do I have to do? Antiderivative, good. If we want after 10 months, then we need to integrate from 0 to 10. And since my variable is t, we put a dt on the end of that. Remember, every time you have the integral, you have the dx or dt or whatever at the end. When the integral goes away, so does that. So the antiderivative of 10 would be 10t. Antiderivative of t would be 1/2 t squared. This would be a t cubed, so if I take 0.06 times 1/3, we get 0.02. So if we plug in 10 squared is 100 times 1/2 is 50. 10 cubed 1000 times 0.02, and that gives me minus 0. Okay, I get 170. This is not the final answer though. This tells me how the population changed over that time period. So it's saying in that 10 months you added 170 to your population. So what's my final population? 270, because we started with 100. And this means we added 170. So final population is 270. All right. Let's stop there for today.